So till now I have configured IP address only, exclude unassigned. On router number 1, you can see on fast Ethernet 0/0 I am running this IP address 192.168.10.1, and on serial 2/0 on WAN link I am running this IP 1.1.1. Apart from it, I have not configured netting or default route, right? So we will configure default route and netting here. On router number 2 also you can verify the IP, so IP interface brief exclude unassigned, right? On router number 2 LAN interface I am running this IP 10.2, and on WAN interface 2.2.2.1, and router number 3 so IP interface brief exclude unassigned, right? On LAN interface I am running .3, and on WAN interface 3.1. So as you know, on PC number 1, let's say if I will define default gateway, what this one 192.168.10.1, right? Then PC 1 can access internet via router number 1. If I will define this default gateway on PC number 1, then PC 1 will reach to internet via router number 2. If I will define this IP address as default gateway to PC number 1, then definitely PC 1 will reach to internet via router number 3. But as I told you in last class, that we are not going to define physical IP address of default gateway. We will create virtual IP address with the help of HSRP protocol, and we will define that virtual IP address as a default gateway on LAN users, right? So this IP address is going to be my virtual IP address. Okay, so from R1 you can see I am able to ping ISP ping 1.1.2, right? From R2 ping 2.2.2.2, done. From R3 ping 3.3.3.2, done. But I cannot ping 8.8.8 because default route is required here, right? So let me configure one default route on all edge routers first. IP route 0.0.0, 0.0.0 and 1.1.2. Now do ping 8.8.8. Now I am able to ping 8.8.8 from WAN interface, but again I cannot ping 8.8.8 from LAN interface. For that I have to configure translation. So let me configure PAT. On serial 2/0 IP NAT outside exit interface fast Ethernet 0/0 IP NAT inside. Fine. Then I need to create one access list, let's say number 10, and say permit 192.168.10.0 wildcard mask 0.0.255. Then IP NAT inside source match from list number 10 and translate it into the IP address which is running on serial 2/0 and say overload. Fine. Now I can ping 8.8.8 from LAN interface also, ping 8.8.8 and say source fast Ethernet 0/0. You can see, right? Ping is working. I need to do same thing on router number 2 also. So let me take you to R2 interface serial 2/0, say IP NAT outside exit interface F0/0 IP NAT inside exit access list number 10 permit 192.168.10.0 0.0.255. Then IP NAT inside source list 10 interface serial 2/0 overload, right? From here I can now ping 8.8.8 from LAN interface, ping 8.8.8 source F0/0. Why I am not able to ping? Because of default route. So let me configure one default route as well here. Say IP route 0.0.0 0.0.0. Next stop is 2.2.2.2. Right now let me verify the connectivity. You can see from LAN interface I am able to ping 8.8.8. Let me configure same on R3 also, interface serial 2/0, say IP NAT outside exit interface fast Ethernet 0/0 IP NAT inside, and then exit IP route 0.0.0 0.0.0 and 3.3.3.2. okay. Then access list number 10 permit 192.168.10.0 wildcard mask 0.0.255. Then IP NAT inside source list 10 and interface serial 2/0 overload. Here also I can ping 8.8.8 from LAN interface 8.8.8 and source fast Ethernet 0/0. Done. Clear guys? I'm going to close the console of ISP, and here let me access PC1. On PC1, if I will define any IP address 10.1.1. let's say 10/24, and if I will define gateway of router 1, let's say 192, sorry, here IP address will be 192.168.10. let's say 10/24, and gateway is 192.168.10.1. right? Now this PC cap access internet can ping 8.8.8 via router number 1, right? But what is problem here? If router 1 will goes down, manually I have to change default gateway. Manually I have to change default gateway, right? Clear guys till here? So now you can see path. 10.1 is the IP address of router 1, and this is the IP address of serial 0/0 on ISP router. Clear? So if R1 will goes down, manually here I have to change default gateway. Otherwise, this PC cannot ping 8.8.8, right? So here I am going to define virtual gateway 192.168.10.100/24. Sorry, IP
Sir,
address is, yes. Going to define virtual gateway 192.168.10.100. Now this PC cannot ping 8.8.8 because we have not configured this virtual IP address till now. So you can see ping 8.8.8. Again, my ping is not working. Why ping is not working? Because PC1 is not able to resolve MAC address of default gateway. So ARP. You can see in the ARP table, we don't have any MAC address with the corresponding of default gateway. So now let me take you to R1 and see guys how we will enable HSRP. So we will run HSRP command on interface. Interface fast Ethernet 0/0. This is my LAN interface. Here I am going to say what? Standby and then group number. Let's say group number 10, or I can use any group number 1, and then IP. After that, virtual IP address. What virtual IP address you are going to configure here? 192.168.10.100. Right? That's it. This is configuration. How to verify? So standby brief. So you can see here by default, as I told you, priority will be what? 100, and for now active router is unknown and standby router is also unknown, but after 10 seconds this router will become active, right? And priority is 100, group number is this one, virtual IP address is this one, right? Standby router is unknown, and now you can see state move from standby to active. Now this router is active. You can see active router is local router and standby is still unknown, right? Because this router is not receiving any hello message of HSRP from their neighbor, from any other router, right? Because of that, standby router is unknown here. Now if I will ping again 8.8.8, will ping work? You can see ping is working now, right? Ping is working now because now R1 is responding to ARP request. So ARP. So ARP. Here you can see we have one MAC address with this IP address, gateway IP address. So this is HSRP configuration on router number 1. We can check detailed configuration as well by running command so standby. So standby, see the output here. First of all, state of this router is active. State of this router is active. Virtual IP address is 192.168.10.100. Virtual MAC address is, as I told you, virtual MAC address, these value will be always same, and last two value will be what? Group number. So my group number is 1, so that's why you can see in last MAC address is 01. Okay, then hello timer is 3 seconds, hold on time is 10 seconds. Next hello message, it is going to send next hello message after 1.520 seconds. By default preemption is disable. Active router is local router and standby router is unknown. Priority is 100 and this is group name. Clear guys? Clear?
Clear.
Okay, now I am going to enable HSRP on router number 2. Again, interface fast Ethernet 0/0, say standby, group number 1 and virtual IP address 192.168.10.100, right? Again, here I can run command show standby brief. So you can see standby router is unknown now. Soon these router are going to exchange hello messages, right? Soon router 2 will receive hello message of router 1 and router 1 will receive hello message of router 2. Then router 2 will become a standby, because as I told you, by default preemption is disabled. Otherwise router 2 should become active router, right? But preemption is disabled and active router is still there in this group. So router 2 is going to become a standby router, right? Standby. And here you can see active router is 192.168.10.1. This is IP address of R1, and standby router is local router, and virtual IP address is this one. By default, again, priority is 1, group number is 1. But by priority is 100 and group number is 1. Here also group number is 1, priority is 100. These are by default. Now, when I will enable HSRP on router number 3, then router number 3 will be in listening state, or router 3 will become a standby router, guys. So for standby preemption is enabled. So router 3 have higher IP address than router number 2. So router 3 will become what? A standby, and router 2 will be in listening state. Router 2 will be in listening state. So let me configure R3, HSRP on R3. So this is output of show standby brief command, and here we can check detailed information as well, like by running command show standby. So here also you can see the output. State is standby, virtual IP address is this one, virtual MAC address is same, hello time 3 seconds, hold on time 10 seconds, preemption is by default disabled, active router is 192.168.10.1 whose priority is 100, and standby router is local router, priority over here is 100, and this is name of group. Now let me enable HSRP on router number 3. So on R3 interface fast Ethernet 0/0, say standby, group number 10, sorry, group number let's say 1, and IP 192.168.10.100. So standby. So standby, we can say brief. Standby router is 192.168.10.2, but now you can see this router is standby because router 3 have higher IP address. Priority is by default same on all routers, but router 3 have higher IP address. Because of that, router 3 have become a standby and router 2 is in listening state. So here now I can run command show standby brief. You can see this interface, priority this one, group this one, state is standby, active router IP address is 192.168.10.1, means router 1 IP address, standby is local router and virtual IP address. Now on R2, again if you will run this command show standby brief, you can see state of this router is listening. So even let's say if we have some more routers, router 4, router 5, so all other router will be in listening state. In one group, only one router will be in active state and only one router will be in standby state. All rest routers will be in listening state. Right, guys?
Why the 10.3 become active?
Yes, I am also that same question.
10.3 is not active, na? 10.3
No,
is
standby.
Because router 3 have higher IP address.
Because here that in HSRP you are saying that the preemption is disabled.
Preemption is disabled for active router. Preemption is enabled for standby. How many times I told you this? Preemption is enabled for standby. Preemption is disabled for active router only. And preemption for active router will also not work. Even you will enable preemption over here, then also preemption will not work. So preemption never work with default priority. So if I will see here, if I will enable preemption on router number 1, interface F0/0 standby group number 1 and say preempt. So standby. Now preemption is enabled over here. On router number 2 also I am going to enable preemption. So this is preemption for active router. Standby group number 1 preempt. So standby. Preemption is enable on router number 3. So sorry, 150 interface F0/0 standby group number 10 preempt. So standby. Preemption is enable, but still which router is active router?
Group number 1. You gave 10.
Yes, yes. Group number 1.
Preemption is enable, right? So now router 3 should be active router, but you can see so standby brief. Which router is active router? 10.1 means router 1. So preemption for active will not work with default priority. But on R3 if I will change priority, interface F0/0 standby group number 1 and priority, let's say 110. Now you can see this router is my active router. Active router is local router. And which router is a standby router? Which router will become a standby here? Router 1 or router 2? Router 2 have highest IP address than router 1. So router 2 is my standby router, router 3 is active router, and router 1 is in listening state. Now here you can see between router 1 and ISP we have 8 Mbps link. Between router 2 and ISP we have 4 Mbps link, and between router 3 and ISP we have 2 Mbps link. So this is my primary link, this is my secondary link, and this should be my backup link, right? So how I will configure the scenario? On router number 1 I should configure higher priority. On router number 3 I am going to set priority what? Interface F0/0 say standby group number 1 priority, let's say 105. On router number 2 I am going to set priority, let's say 110. Interface F0/0 say standby group number 1 priority 110, and router number 1 I am going to set priority 120. Interface F0/0 say standby group number 1 and priority 120. So now router 1 will become active router, router 2 will become a standby router, and router 3 will be in listening state. So standby brief. So this router is active router, standby is unknown, soon router 2 will become a standby router. Now you can see, right? And on router number 3, so standby brief, this router is in listening state. Clear? So again from PC1 if I will trace 8.8.8.8, you can see my traffic is going via router number 1. If router 1 will goes down, interface F0/0 says shut down. Now router 2 will become active router. So if you will trace again to 8.8.8, you can see two 192.168.10.2 IP address of router 2. That means now my router 2 is active router. On router number 1, so standby brief. Here you can see active router is also unknown and standby router is also unknown. So whenever you will see this problem, right, active and standby both are unknown, that means there is no connectivity between two default gateway. So here I have shut down this interface F0/0, right? So that's why we are able to see active is unknown and standby is unknown. Sometime you will see both router will show you active. Means if R1 is also saying I am active, router 2 is also saying I am active. That means both routers are not able to exchange HSRP hello messages, right? So if R1 will not receive any hello message from any other router, right, then R1 will say what? I am active and standby is unknown, right? But on router number 2, so standby brief. You can see local router is active router and standby is router number 3. Again, when router 1 will come up, router 1 will become what? Active. Interface F0/0 say no set. Active router is router 2, and now you can see the active router is local router. Standby router is router number. Standby router will be router 2, not router 3, na? Router 2. Clear? So this is HSRP. Any question? See, ping is working. Yes. Any question? Can I configure VRRP now?
If preempt is enabled, whatever router having higher priority, that will become active, right?
Yes.
Am I right? Okay.
Yes. Clear? Now, okay. See, now PC1 is able to ping 8.8.8. Yes.
We need to configure preempt in all the routers, or the router, what we can configure in only one router also?
No, no. You have to configure it on all routers.
Preempt on all the routers.
Yes. Now, if link between R1 and ISP will goes down, then what will happen? If link between R1 and ISP will goes down, let's say serial 2/0 shut down. Now, so standby brief. Still, which router is local? Active router. Local router means R1. Then PC cannot ping 8.8.8. Again, destination host unreachable. Right. So what is happening? Router 1 is my active router in this scenario, but there is no connectivity between ISP and R1. So this time, if LAN interface will goes down, right, then only R2 or R3 will become active, right? If this link will goes down or ISP will goes down, right, R1 will be my active router still, right? So in this scenario, what I need to do, I need to track this link. I can track this link. I can tell to router, please track this link if line protocol of this interface is up. If line protocol of this interface is up, let's say this link will goes down, then line protocol of 0/0 on router number 1 will down. So if line protocol will goes down, right, please decrement priority by, let's say 20. So here configure priority is what? 120. Here configure priority is what? 110. Here configure priority is what? 105. So if track will goes down, it will decrement priority by 20. Then what priority will become here? 100. So automatically router 2 will become what? Active router. Automatically router 2 will become what? Active router. Clear? If I will decrement priority by 5, then what will happen? If I will decrement priority by 5, whenever track will goes down, please decrement priority by 5. So configure priority is 120, it will decrement priority by 5. So what will be priority over here? 15. 115. So still you can see router 1 have higher priority. So still router 1 will be my active router. So make sure when you are tracking the link, you should configure, correct decrement in priority. So let me show you this also. Like here you can see PC1 is not able to ping because my router 1 is active router. Router 1 is my active router, but link between ISP and router 1 is down. So IP interface brief. This link is administratively down. So first of all, I am going to up this link, interface serial 2/0, say no set. Right. Again from PC1, you can ping and ping will work.
So what is the default decrement value for the track?
10. Default decrement is 10. Yesterday also I told you this in theory part. So now I am going to track serial 2/0. So see, command is interface F0/0, say standby interface serial 2/0. This is command. Right now you can check track. So track. So my track is up. Line protocol is up. Right. So track 1 via HSRP tracking line protocol of serial 2/0. Line protocol of serial 2/0. So if this track wheel goes down, it will decrement piety by 10. So here piety will become what? 110. Okay, but it should decrement priority at least 11, right? So router 2 can become active router. Otherwise on both router priority is same, but again router 2 have higher IP address, so router 2 will become active router. So what I am going to do, I am going to again down interface serial 2/0, interface serial 2/0, say shut down, and so track. So you can see my track is down. So whenever track will goes down, it will decrement priority by 10. So standby brief. Here priority is what? 110. And so standby, you can see configured priority over here is 120 and current priority is 110, because it have decrement priority by 10 because track is because track is down. Again when track will, so standby, configure priority and current priority both are 120. Right now I am going to decrement priority 20 whenever track will goes down. What I want, it should decrement priority by 20 or by 11 whenever track will goes down. See, in this scenario what I want, if router 1 is active and there is reachability between ISP and router 1, then router 1 should be my active router, router 2 should be my standby router, and router 3 should be in listening state. Right. So here priority is 105, here priority is 110, and here priority is 120. So if I will decrement priority by 11 whenever track will goes down, then here priority will become what? 109. So you can see on router number 2 we have what priority? 110. Here what priority we have? 109. So router 2 will become what? Active router, and router 3 will become a standby if router 1 will goes down. Fine. So let me do that. Here again on R1, do so run interface F0/0. First of all I am going to remove this command. Say no to this, and then say standby number 1 track decrement and decrement, here we can say decrement by, let's say, 11. This is command. Now if serial 2/0 will goes down, interface serial 2/0 says shut down to this interface, track will goes down, you can see track is down, and this router move from active to speak state. Now here you can run this command, so standby brief. So active router is now router number 2. Active router is router number 2. And standby router is still router number 1. Why? Because on router number 1 we have what priority? 109. And router number 3 we have what priority? 105. So router 1 is standby router. Clear? And see the output of so standby command. Here configured priority is what? 120 and current priority is 109 because of track, because my track is down. Again, when track will come up, interface serial 2/0 say no set. Right, track will come up, it will add priority 20. So standby. You can see here priority now is 120, and because of this, so standby brief. This router is active router. Even ISP interface will goes down. Let's say on ISP, I'm going to down serial 2/0 interface serial 2/0 say shutdown. Again, line protocol of serial 2/0 on router number 1 will goes down. So IP interface brief. Soon line protocol of this interface will be down. Right? This is GNSC. That's why it's taking some time. Soon you will see line protocol of this interface will goes down. Okay, now you can see line protocol is down. Because of that, my track is down, up to down. And when track will goes down, it will decrement priority by 20. So this router is now a standby router. Clear? Okay, here priority is 109. So what I want, if link between R1 and ISP, whenever link between R1 and ISP will goes down, R1 should not be a standby router, right? R3 should be my standby router. Then I should decrement priority by, here priority is 120, here priority is 110, here priority is 105. So I should decrement priority by, let's say 20, right? So here priority will become what? 100. So router 2 will become active and this router will become standby. So first of all, on ISP router, let me run no set command again. Interface serial 2/0 say no set. Again, line protocol of serial 2/0 on router 1 will come up, then track will come up, and when track will come up, it will add priority by 20. So here by 11. So priority over here is going to be 120. So IP interface brief exclude unassign. Right, line protocol is up, so track. So track is up, and so standby. That's why you can see priority is 120, and because of this, so standby brief. This router is my active router. Yes, guys. Clear HSRP? Is HSRP clear to everyone?
Yes, sir.
Yes.
Can you do IP SLA?
Okay. See, let's say here router 1 is connected with different ISP. We have connectivity from 3 different ISP. Here router 1 have connectivity from, let's say, ISP 1, router 2 have connectivity from ISP 2, and router 3 have connectivity from ISP 3. So when we will track this link, right, then definitely if this link will goes down, track will goes down and it will decrement priority. In priority. But if ISP will goes down, let's say here we have one loopback 8.8.8.8. If this loopback interface will goes down, right, then track will be up here, because track is tracking what? This link, line protocol of this link, right? So if you want to track ISP, now I want to track 8.8.8, that until and unless 8.8.8 is reachable from router number 1, right, then track should be up. If 8.8.8 is not reachable from R1, then track should be down, and when track will goes down, it should decrement priority by 20 or by 10, 11, anything. So for that scenario, what I can do, this is guys inbuilt feature, this is inbuilt feature of track in HSRP, right? For track 8.8.8 from R1, you have to create external track, right? For that you have to create IP SLA to send ICMP packet to 8.8.8 continuously. So what I can do on R1, first of all, I am going to remove this track configuration, interface F0/0, and say no, do so run interface F0/0. I'm going to remove this command, right? And now I'm going to create one IP SLA, say IP SLA, and then SLA number is, let's say, 10. Here I'm going to say echo ICMP echo. ICMP echo request means I am creating IP SLA for ICMP echo request. It will send one echo request to 8.8.8, right? From which interface? From, we can say, source interface serial 2/0, right? Now here if you will debug IP ICMP, here we are not able to see any ICMP message. Actually I have created SLA. Now I have to schedule this SLA. To schedule this SLA, you need to run this command IP SLA schedule, and then SLA number was 10 or 1?
10.
10. Okay, so 10, and then we can say start time, when you want to start this IP SLA. So let's say now I want to start now, and for till when you want to run this. So say for life forever, and now you can see it have started sending ICMP echo request to 8.8.8. On ISP also you can see it is receiving ICMP echo request message, it is generating reply to 8.8.8, right? And now I am going to call this IP SLA with track. So here I can create one track number 10, IP SLA number 10, reachability. Fine. Now so track. My track object number 10 is up or down? Up. Why track is up? Because 8.8.8 is reachable. If I will down this interface on all, if I will down loopback interface here, interface loopback 1 says shut down to this interface. Now on router number 1, so track, soon track will goes down, ping 8.8.8, right? So ping is not working on all, so track, my track is still up. Actually, it's taking some time, right? Now you can see your track goes down. So what we can do here, we can configure, frequency IP SLA 10. NTL redealing we cannot modify. Okay, say no IP SLA 10 and say IP SLA 10 again. ICMP echo to 8.8.8 from source interface serial 2/0, and here I can set frequency 5. So after 5 seconds it will send one ICMP packet to 8.8.8. Now again I have to schedule this IP SLA. So say IP SLA schedule number 10, then life or start time, now life forever. So track. So my track is done. Now I am going to run no such command here on loopback interface of ISP. So track will come up. You can see now track is up. Track is up. And now I am going to call this track with HSRP. So let me take you to interface fast Ethernet 0/0, and here I can say standby group number 1 track number 10 and decrement in priority by, let's say, 20. Now this is configuration. Now see, on ISP again I am going to run no shutdown command on loopback interface. So on router number 1 track will goes down. Track will goes down. Here you can see track is reachability, there is no reachability. Now so track is down. So if track will goes down, it will decrement in priority by 20. So standby brief. So here you can see priority is what, 100. So active router is router number 2, standby router is router number 3, right? Again if track will come up, again if there is reachability from serial 2/0 to 8.8.8, then track will come up. You can see track is up. Now again HSRP state is speak to active. Now this router is my active router. So standby brief. Okay, Dhana?
Okay, sir.
Now can I move to VRRP?
Can we do IPSLA in F0/0 also?
F0/0. This interface.
Yes.
Why you will track this interface? If this interface will goes down,
Source,
it will stop sending hello message now from here.
source from that interface. Source
From where?
source from F0/0 to 8.8.8.
Yes, you can define this interface also na, as a source interface. Yes, of course. From this interface also we have reachability to 8.8.8 na, so we can define this interface also as source in IP SLA.
Okay, sir.
In same scenario it will work fine, right? Now VRRP is also, guys, exactly same like HSRP, but again VRRP is open standard and HSRP is Cisco proprietary protocol. So I am going to remove HSRP configuration from router 1, 2, 3. So first of all on router number 1 I am going to say no IP SLA 10 and say no track 10 also. I have removed track configuration and IP SLA configuration. Then interface F0/0 do so run interface F0/0. I'm going to remove these all commands. Say no to this. Fine. and do show history. I'm going to copy. Oh, priority is different now on each router. Interface F0/0 do so run interface F0/0, say no, do so run interface F0/0. Okay, so run interface F0/0. So default configuration. Okay, interface F0/0 do so run interface F0/0. Let me remove this all command from this interface also. No, I have removed HSRP configuration from all routers, from router 1, 2 and 3. So standby. Now you can see we are not able to see any output. So again PC1 cannot ping 8.8. Ping is still working. So ARP. Clear ARP. So ARP, right? And now ping 8.8.8. Fine. So see now how you will configure VRRP protocol here. Again on router number 1, go to LAN interface F0/0 and say VRRP, then group number, let's say 1, and then IP. And guys, if you want to change timer or those things in HSRP, you know, command will be this one, standby, group number, and then timer. This is command. Then you can define hello time, then you can define hold on time. Like this, you can change timer in HSRP, right? VRRP group number 1, IP 192.168.10.100. This is VRRP configuration, right? On router number 2 also, interface F0/0, VRRP IP 192.168.10.100, VRRP group number 1, IP this. On router number 3, interface F0/0, VRRP group number 1, IP 192.168.10.100, right? So here I can run so VRRP brief. So this router is master router. Why this router is master router? Because this router have highest IP address, and priority on all router is, you can see by default, 100. So VRRP brief. This router is backup router. Master router is 192.168.10.3. On router number 2, so VRRP brief. So configuration is exactly same. In VRRP, one router will be active router and all other router will be in backup. All other router will be backup router. So active, when active will goes down, again backup router will come up, will become active router. Means router who will have highest IP address if priority is same on all routers. And so VRRP state is backup, virtual IP address is this one, virtual MAC address is again, you can see this one, right? Preemption is by default enabled. Preemption is by default enabled in VRRP. Master router IP address is 10.3, priority is this one, right? These are same output. Here also on router number 1, I want router 1 should be my active router. So interface fast Ethernet 0/0, I can say VRRP group number 1, priority 100, 20. So you can see the log message. Now this router is my master router. So VRRP brief. Right. What I want, when R1 will goes down, R2 should become master router. So on R2 I am going to set priority what? 110, let's say, interface F0/0. VRRP group number 1 priority. On router number 3 I can set 105. VRRP group number 1 priority. Right. Again from PC1 I am going to ping 8.8.8. You can see ping is working, and router 1 is my active router. So here we can trace as well. Trace 8.8.8. Right. So traffic is going via router number 1. When R1 will goes down, interface F0/0 says shut down. Which router will become master router? Router 2. So from PC, again if you will trace, right, so my now traffic is going via router number 2. Again if router 1 will come up, router 1 will become master router. So by default preemption is enabled over here in VRRP. Then we have last protocol, that is GLBP. Guys, here I have single group number 1. In group 1 this router is master router, this router is backup router, this router is backup router. Here priority is what? 120. Here priority is what? Here priority is 110, and here priority is 105, right? So for all these user, router 1 is my master router, right? That means these all user will access internet via router number 1. So let's say what I want that for these two user, these two users should be able to access internet via router number 1, and this user should be able to access internet via router number 2. So what I can do, I can create one more group here, group number 2, and in group number 2 here I will set priority what? 105. Here I will set priority what? 110, and here I will set priority what? 120. So for group 2, which router is active? Router number 3. Let's say here I have defined virtual IP address 192.168.10.100. Here I have defined virtual IP address 192.168.10.200. So I will define this default gateway to PC number 3 and this default gateway to PC1 and PC2. So it will work same. So if you want to achieve load balancing, let's say here we have some user in VLAN 10 and we have some user in VLAN 20. So for VLAN 10 user, I want to write router 1 should be my active router. For VLAN 20, router 3 should be my active router. So for that scenario, you can create multiple groups. Working will be same. There's no any difference when we have multiple group. Okay. Let's say here on router number 1, interface F0/0, VRRP group 10, IP 192.168.10.200. Right, let me copy this command. Okay, and here let me set priority as well. VRRP group number 2, priority 100, right, and do okay. Now R2 VRRP group number 2, IP 192.168.10.200, VRRP 2, priority 110. On router number 3, VRRP group 2, IP 192.168.10.200, and VRRP 2, priority 105. So you can see on router number 1. Now if I will run command show VRRP brief, this router is master router for which group? Group 1, and this router is backup router for group 2. On router number 2, show VRRP brief, this router is master router for group 2 and this router is backup router for group 1. Now on PC1 I'm going to define what default gateway, same 192.168.10.100. On PC2 I'm going to define 192.168.IP 10. Let's say 20/24, and here I will define default gateway what 10.200. So PC2 will access internet via router number 2. From here if you will trace 8.8.8, see traffic is going via router number 1. From PC number 1 if you will trace 8.8.8, traffic is going via router number 1. So if we have multiple group, then also working will be same, right? There is no any difference. Fine. Can I remove VRRP configuration?
Yes, sir.
Okay. So interface F0/0, say do so run interface F0/0. Say no to this command, no to this command, and no to this command. On router number 2, config T interface F0/0 at no do so run interface F0/0. This command and no to this command also. Now one minute guys. Let's understand some theory part about GLBP protocol first, then I will come to configuration. Okay, so this is my topology. Guys, again GLBP protocol is Cisco proprietary. You can run GLBP only on Cisco devices. Only on Cisco devices. Now when we will configure GLBP on these 3 routers, one router in a single group, one router will become AVG. One router will become AVG router, and all router will become AVF router. AVG stands for active virtual gateway, and AVF stands for active virtual forwarder, right? So in one AVG, in one group of LACP, how many forwarder routers are there? 3. All routers will become what? AVF, right? Router 1 is going to become what? AVF. Router 2 will be also what? AVF, and router 3 is also what? AVF. AVF are those routers which is going to send IP packet, So in this scenario, all router will be my AVF, means all routers are going to send IP packet. So all router 1, 2, 3, all routers are going to forward packets of these user. And AVG is not used to forward IP packet. AVG is responsible to response ARP reply message, to response ARP request message. Whenever PCs will generate ARP request message, AVG router is responsible to provide MAC address. So what AVG will do, here we have 3 routers, right? So one router, let's say my router 1 is AVG router who will have highest priority and highest IP address. That router will become what? AVG. There will be only one AVG. Okay, and AVG router will be also AVF. This is AVF 1, this is AVF 2, this is AVF 3. So we have 3 forwarder in one and one AVG. Now when PC1 will generate ARP request for this virtual IP address 192.168.10.100, AVG will provide MAC address of forwarder 1. When PC2 will generate ARP request, AVG will provide MAC address of forwarder 2. When PC3 will generate ARP request message, ABG will provide MAC address of ABF3, forwarder 3, right? Again, when any other user will generate ARP request, ABG will provide MAC address of forwarder 1. Again, it will come to forwarder 1. Okay, so AVF is responsible for forwarding IP packet, and AVG is responsible to forward to resolve to see here, you can say MAC address of forwarder. So AVG will be also AVF, and router 2 will be also AVF, router 3 will be also AVF over here, right? So this is how in GLBP we are achieving load balancing by default. In a single group we are achieving what? Load balancing. If any router will goes down, let's say router 3 will goes down, right? So AVG will remove router 3 from their forwarder list, from their active forwarder list, right? Then AVG will provide MAC address of forwarder 1 and forwarder 2 only. This is right. X-axis is group number and YY is forwarder number, right? So router 1 is forwarder 1, router 2 is forwarder 2, and let's say router 3 is forwarder 3. So what will be virtual MAC address of forwarder 1? 0007.B4 00.group number 01 and forwarder 1001, right? What will be MAC address of AVF2 forwarder 2? 2. And what will be virtual MAC address of forwarder 3? 3. Here. This is concept of GLBP. Now configuration is exactly same. Let me show you configuration. On router number 1, interface F0/0, GLBP group number, let's say 1, and then IP 192.168.10.100, right? So GLBP brief. Okay, it will come soon in forwarding state. And so GLBP, you can see here that two information. This is information of ABG. This is information of AVG, and this is information of AVF. So there is one forwarder. There is only one forwarder, right? This router is forwarder router, as well as this router is gateway router, AVG, right? In the same way, on router number 2, interface F0/0, 0/0, GLBP group number 1, IP 192.168.10.100. On router number 3, GLBP group number 1, IP 192.168.10.100, right? Let me take you to R1 again. On R1, how many forwarder we have now? 2 forwarder, and soon it is going to receive GLBP hello message from R3. Then you will see 3 forwarder are there. There will be 3 number of forwarder. Now you can see there are 3 forwarder, right? So when R1 will receive first packet, it will provide MAC address of forwarder 1. This is forwarder 1 information. This is forwarder 2 information, and this is forwarder 3 information, right? So when ABG means router 1 will receive first packet, first R packet, it will provide this MAC address. To second ARP request, it will provide this MAC address, and to third ARP packet, it will provide this MAC address, right? So what we can do, we can verify it from PC1. From PC1, I'm going to first clear ARP, and let me ping 8.8.8.8. See, I'm able to ping 8.8.8, and if you will check MAC address table, sorry, ARP table, so ARP, you can see this is MAC address of forwarder 101, right? If I will clear ARP, and if I will ping again 8.8.8, so this time AVG will provide MAC address of forwarder 2. Now you can check again MAC address, sorry, ARP table, so IP ARP, you can see, right? Again, if I will clear ARP, and again if I will ping 8.8.8, this time AVG will provide MAC address of forwarder 3. So ARP, done. So in GLBP we can achieve load balancing by default, right? After that, again priority configuration, preemption configuration, right? Those are exactly same like HSRP. Both are Cisco proprietary. So here also in GLBP you can see by default preemption is disable. Clear? So this was, guys, all about first hop redundancy protocol. What we call it? FHRP, first hop redundancy protocol. Any question?
How the AVG election takes place?
Highest priority and then highest IP address. Same like HSRP. As I told you, election criteria is same.
Why you are clearing the ARP and checking?
If I will not clear the ARP, so it will store ARP entry for 4 hours in their ARP table. Na? So for 4 hours, PC1 will communicate via router number 1. After 4 hours, it will generate ARP request. So that's why I was clearing ARP table. Like again, if PC1 have this MAC address of forwarder 3. If PC2 will ping 8.8.8, PC2 will get again MAC address of forwarder 1. PC2 will get MAC address of forwarder 2. Sorry, 1. So ARP. Or we can trace as well. Trace 8.8.8. Right? If you will trace 8.8.8 from PC1, you can see PC2 is communicating with internet via router 2, and PC1 is communicating via router 2, and PC2 is communicating via router 1. If I will clear ARP table, so again it will generate ARP request message, and it will get MAC address of forwarder 2 now. So this type of load balancing is called round robin load balancing algorithm. This is round robin load balancing algorithm. Router is forwarding one packet from one AVF. First packet to first AVF, second packet to second AVF, third packet to third AVF, then again fourth packet to first AVF. Done.